Welcome to my channel. Your tutor Mariam is here. It's the 10th video of Introductory Physics 1 and the 6th video that I'm going to talk about the motion, which is the second topic of Introductory Physics 1. In this video, I'm going to talk about the equation of motion and where we can use this equation. And at the end of the video, I'm going to solve one problem. So if you are interested in Introductory Physics 1 and would like to get a good grade in your exam, I highly recommend you to hit the subscribe button and like for more. You ready? Let's get started. In your textbook, you're gonna see a couple of equations for motions. And here I wrote 4 equations that you might use for the most problems. So the difference between this equation is the values you have. Sometimes you have displacement, acceleration, and looking for time, right? So equation 1 would be the best things to choose. Sometimes you have a time independent problem, like you're not looking for time, and also your problem didn't give you the value for time. So equation 2 would be a best choice because you have the velocity, initial velocity, acceleration, and displacement. Let's look at equation 4. You have the initial value for velocity, acceleration, and time, right? So it depends what you want and what your problem give you. You can use the different equation, right? But let me tell you something. As an instructor, we consider how much time you need to spend on one problem in the exam. So let's say you have 30 minutes for your exam and you have 10 problems, right? We consider 2 minutes for each problem. So 2 minutes, 10 problems is going to be 20 minutes, right? So as an instructor, I expect you have 10 minutes more for reviewing your solution and see if you made a mistake or not, right? So how I consider this time? Let me give you an example. For example, you have the problem that gives you a displacement, initial velocity, and acceleration. And it's asked about the time, right? So you can use equation 1 or 4, correct? So what I expect you to do is solve the problem with equation 4, right? Because it's linear and it takes like 2 minutes or even less to solve it. If you go with equation 1, you still can solve the problem, right? And you're gonna end up with the right answer. But the problem is you're not gonna spend 2 minutes. You're gonna spend 5 minutes, 4 minutes, or because this problem is not linear, your answer won't be right, right? So what I'm suggesting you guys do in your exam to save your time is write down all values you have and also write down which part or which value your problem asks you. And then start to look at the equations for motion and see which one is the best and then go for it. This is the best way to solve the equation because most of the time you might find you are out of time and you don't have time to go through all of the problems because you're stuck in 1 or 2 problems. So sometimes you use equation 1 to find something, go with equation 2 to find another value, and then, for example, go to equation 3 to find what your problem asks you. Okay, so most of the time, this is not the way you should solve the problem. Most of the time, you're gonna go with a straight equation and solve it. That's why you are out of time in your exam. So for making it clear, let me solve one example for you. So in this question, a car has a speed of 60 meters per second, right? And then it's asked about the acceleration if it stops in 2 seconds. Part B, it says that if car starts at point X at the position X equal to 0, and then what's its final position, right? Let's solve part 1 first. So here I have a car with a speed of 60 meters per second, right? So that says I have the car with a velocity of 60 meters per second, right? And it says what's going to be the acceleration if it stops in 2 seconds, right? So my time also is 2 seconds, right? But pay attention to this word. It stops. What that means here. So if it stops, that means my V1 gonna be 0, right? Because if it stops, there is no velocity in there, right? And it's asked about the acceleration, right? So we're looking for the acceleration. Let's look at the equation of motion. Let's see if I can use equation 1. Did it ask about the displacement? No. Do I have the value for displacement? No. So I can't use equation 1 for sure. How about equation 2? I do know the velocity. I don't know about the acceleration, and I don't know about the displacement, so not for equation 2. Equation 3 is the same because I don't know about the displacement. How about equation 4? I think I can use it, yes, because I have the initial value for the velocity. I have the final velocity, time, and I'm looking for the acceleration. Let's substitute the value. So my V1 gonna be 0. That's the point you have to be careful here, because your final velocity is 0, not your initial velocity. You had a car, it's moving, and then is a stop. So your final velocity is going to be 0. Your initial velocity is 60, right? You're looking for the acceleration, and time is 2, right? So if I solve it, it's going to be minus 60 equal to 2a, and then my acceleration going to be minus 30 meter per second square, right? That's the answer I'm looking for. And that makes sense. Your acceleration is negative because your speed going to drop, okay? Now let's look at part 2. So let me write down what I have again. So again, my V0 gonna be 60. My V final is 0 because it's a stop. T equal is 2 seconds, right? And then I do have the position, which is x not gonna be 0 because it's a start at this position, right? So it's gonna be my x naught, and then it's asked about the final position, right? And also from the previous problem, I know the acceleration is minus 30 meter per second square, right? If you don't know about these units, or you have the problem with this, I explain it in the playlist 1. I call it as a measurement. And also I put the link below. So feel free to watch that video too. Let's go back to this problem and look at the equation of motion and see which one we can use. Let's go for the equation 1. So I'm looking for the displacement. I do have the acceleration for part A, right? And then I'm looking for the final position. So yes, I can use the first equation, right? Let's look at the other option I have. I don't want to jump to this equation because this is not a linear equation, right? Because the reason I'm saying is not linear because I have a square here, which kind of make my life tough, because in the calculator I should do the square, blah blah blah, and it takes time, right? You know what I'm saying? So let's see if I have another option. I'm gonna save my time. I'm gonna end up with the right answer with the best time I can spend on this problem, right? How about equation 2? I have the initial one. I'm looking for the position, and also I have the acceleration, right? Also can use this one, correct? What about the third one? So I have the time, I have the velocity, and then I'm looking for the position, right? So this is also the good option for me. What about the last one? I'm looking for the position, right? I don't see any position like x in equation 4, correct? So I'm not going to use this. So let's look what I have here. I have 3 equations that I can use, correct? So, and for sure, all of them going to give me a right answer, correct? But another purpose I have is saving my time, right? So what I'm gonna do, I'm gonna go with equation 3. Why? Because this is linear. I can tell you why. So let's look at equation 3 here. I'm gonna use that. So I'm looking for the final position. So x equal to x naught is 0, right? Plus half of time. My time is equal to 2 seconds, right? And then v, my initial is 0. My final is 60, right? So these 2 and 2 cancel out, and my answer gonna be 60 meter, correct? So you can tell I solved it less than 1 minute, right? So, and also I said I can use equation 2, right? Let's go for equation 2 and see what happens. I'm going to use that equation. So my final velocity is 0, right? And then minus my initial one is 60 square equal to 2. I have to use my previous answer, which is minus 30, right? And then x minus 0. Is that right? So if I solve it, it's gonna be 3600 equal to 260 x, correct? And then my final answer gonna be 60 meter. So I end up with the right answer, right? If I use the equation 1 or equation 3 and 2, they both give me the same answer, right? What's the problem here? There are 2 problems. First of all, I spent more time to solving this, like going with the square. Equation 2 is not a linear equation. So it's not easy. That's not easy to solve this problem. The second problem, which is the most important one, is I'm using the answer from the problem, from the part A, right? If this answer is wrong, then part B also gonna be wrong. Imagine for some reason my answer for part A, which I look for the acceleration, was wrong for any reason. Then my answer for part B also gonna be wrong because I use that answer, right? I use that value to put in this equation and then solve it, right? For avoiding this kind of problem, it's better to not use the answer you got from the previous part. It's better to go to the what your problem give you, because in this case, if you lose the point from part A, you still get some point from B, right? But if you use the answer from part A, you are missing the point for all of the problem, right? You still get partial point because it's you write the equation, you have this part, but that's not the best choice. I hope this video helped you to understand the equation of motions better, and if you like my video, please like for more, and I'll see you in the next video.